How's it going, everyone? Well, I have finally done it. I have decided to attempt to give you guys a tutorial on something related to my future career field. And that is, I'm going to hopefully help you guys out there who may be taking some linear algebra or trying to figure out how to multiply matrices. And that is exactly what I'm going to do in this video is I'm going to give a tutorial on how to multiply matrices. Now, I'm kind of giggling about this because here I am with a master's in exercise science, and I attempted a couple of hours ago to make an exercise video giving you guys out there 10 different exercises you could do at home without any equipment, and I was struggling. And here I am, a master's degree in exercise science, and I'm struggling to come up with 10 different exercises. And it goes to show that if you don't put your degree to use, if you don't use it, you lose it. But I'm really excited about this career field I'm going into because, for one, many jobs in my career field involve personal training, and that's a career field where you're pretty much having to be like a salesman. I mean, if you like hustling and bustling, you'll enjoy being a personal trainer. If you like soliciting members and trying to sell them training packages that can cost upwards of $2,000, $3,000, have at it. There's other jobs in the health and fitness realm that I don't really find suitable for myself. So it's kind of one of those career fields where you just kind of have to really know deep down, is this a career field you want to go into? But with that behind me, I'm looking forward to going into this new career field. And with that being said, mathematics play a crucial role in this career field: calculus, statistics, and probability. And yes, linear algebra. And linear algebra is such a huge component in many different machine learning models. And an important component of linear algebra are, of course, matrices. And so with that being said, I'm going to hopefully try to make this video as clear as possible. It's my first full-on tutorial, educational type tutorial. Excuse me for my handwriting. It's not the greatest, but hopefully I'll be able to convey these tools and methods to help you guys better understand how you can calculate matrices. And so first things first, I'm just going to kind of start off nice and easy, and I'm just going to draw a big, huge matrix here. And so I'm just going to put in a series of ones just to make it nice and simple. So I'm just going to put in a series of ones. Okay, so what we have here, and whenever you're like labeling a matrix, it helps to like figure out like how many rows and how many columns does it have. So I'm going to say, let's just say this is like an m by n. Okay, so how many rows do we have? Well, we've got 3 rows. 3. So this is going to be 3, which is going to be for the number of rows, and that's going to be the 3. And then the n could be representative of the number of columns you have. So m represents the amount of rows you have, n represents the amount of columns you have. So we have 1, 2, 3, 4, 5. We have 5 columns. So this is going to be a 3 by 5 matrix. So right here, this is a 3 by 5 matrix. And so we come over here. Let's go ahead and draw a smaller matrix. Let's just say we have 1, 2, 1. Once again, I'm just drawing a bunch of ones. Okay, so here, m times n. Okay, so we have, how many rows do we have here? We got 2 rows. So that's going to be 2, and we have 3 columns. So that is a 2 by 3 matrix. So 2 by 3. Now in mathematics, when multiplying, pretty much we all know that when you use multiplication, it doesn't really order what the order of the numbers are. So like 5 times 6 is equal to 30. Likewise, 6 times 5 is also equal to 30. Now, when multiplying matrices, you may be tempted to think like, let's say we have one matrix that's equal, like let's say that this is A, and we know that this is like a 2 by 3 matrix. And let's say that B is another matrix. Let's say that A is 2 by 3. So let's go ahead and use these examples here. So let's say we want to find, this is A, and this is, let's just make this B. Let's just make this a big B. Okay, so let's say we want to multiply A times B. And I'm going to go ahead and make a new diagram here because this is getting a little full. And I don't want my handwriting to be under my image here. So let's just go ahead and make a couple of quick, easy matrices, once again consisting of ones. So I'm going to have this be a 2 by 7. Have it be. I'm going to just kind of make these really interesting. So I'm going to have this be, and then once again 2, 3, 4, 5, and 6. So how many rows we have here? We have 2 rows. How many columns we have? We have 1, 2, 3, 4, 5, 6. So essentially what we have here is a 2 by 6 matrix. So we have a 2 by 6 matrix here. And let's say over here, I'm just going to hypothetically say that this is a 6 by 1 matrix. We're going to just hypothetically say this is a 6 by 1 matrix. And let's go ahead and give this, let's just label this C. Okay, so is B times C equal to C times B? And the answer is no, they are not equal. And why that is? Well, here's how it goes. When multiplying matrices, there are a couple things you got to consider. You've got these 2 components here. This is the first dimension of the first matrix. This is the second dimension of the first matrix. The first dimension of the second matrix, second dimension of the second matrix. So in order to multiply these 2 matrices together, if we do, let's start off by doing B times C. So we're going to do B times C. The second dimension of the first matrix has to match the first dimension of the second matrix. Let me reiterate. The second dimension of the first matrix has to match the first dimension of the second matrix. So 6 and 6, they match. So that means we can multiply B times C. So what's going to be the resulting matrix? Is it going to, you're figuring out, so what's the resulting matrix? What's going to be the dimensions of it? Well, you see these 2 outer numbers here? This is going to be representative of that M variable, and here it's going to be representative of that N. So what we're going to have as a resulting matrix is going to be a 2 by 1 matrix. So these two inner numbers match, and so we take the resulting outer number. So our resulting matrix is going to be a 2 by 1 matrix. Now let's say we wanted to multiply C times B. So C times B. So we know that C is a 6 by 1 matrix. So we know that's 6 by 1. And then we're going to multiply it by 2 by 6. So a B is a 2 by 6. So does CB exist? Well, do these 2 numbers match? They do not match. And so this does not exist. You can't multiply C times B. You can multiply B times C, but you can't multiply C times B. So this does not work. So CB does not exist. And I'm going to spare you guys my handwriting and not write it out. So C times B does not exist. So hopefully I tried to make this as clear as possible. So we're going to start off with an easy example and then move on to a little more complicated example. So I'm going to come here. I'm going to create a new page here. And we're just going to use a couple of vectors here. Vectors can either come in the form of a row or a column vector. And so I kind of like to think of these as one-vectored matrices. So we're going to go ahead and say A is equal to, let's just go ahead and make this equal to, this is going to be the first vector. It's going to be, let's just do 105. 105. So don't think of this as like 105. It's just, we have 1, 0, and 5. So keep that in mind. Try not to get confused thinking that A is equal to 105. These are actually each separate numbers. And then B, we're going to make this into a column vector, is equal to, because you'll see why I'm doing this when we get to the more complicated example. And let's have this be 3, 2, 3. Let's have that be 3, 2, 3. Okay. So once again, can we multiply A times B together? Yes, we can. Because here we have 1 row, 3 columns. Yes, this is a 1 by 3. And then can we multiply this together? Yes, we can. Because this is 3 rows, 1 column. So we have a 3 by 1. And so these two match. And so we have something interesting here. We're going to have a resulting answer of what's known as a scalar. So we're going to end up having a 1 by 1, which is essentially a scalar value. So let's go ahead and do that right now. So A times B, we know it's going to be a scalar value. So it's equal to, and we're just going to go ahead and draw our square brackets here. So whenever multiplying matrices, you're going to be multiplying the row times the column. And so for each number, each of these numbers, it's going to be separated with a plus sign. And I'm going to go ahead and demonstrate that right now. So remember, it's going to be row times column. So this number over here is going to be multiplied by this number over here. This number over here is going to be multiplied by this number over here. I'm just trying to draw identical shapes. And this number over here is multiplied by this number over here. And hopefully it's not getting too cluttered here. So we're going to have 1 times 3 is equal to 3 plus 0 times 2 is equal to 0. So that's pretty straightforward. And then we have 5 times 3, which is 15, plus 15. So once again, let me reiterate. We have the first number is going to be the first number here is going to be multiplied by the first number here, 3. Then we have 0 times 2 is 0, and then 5 times 3 is equal to 15. So our answer here is 18. So that is the answer of A times B is 18. So that is how you can multiply more simple matrices. Now let's say if we multiplied B times A, so now what we have here is so B, so we did B times A. I'm not going to go ahead and do it all the way, but we have B times A. First thing you want to do first is, okay, B is a 3 by 1. 3 by 1. Okay. Then times, so we have a 3 by 1 times a 1 by 3. So yes, these two numbers match. And so now what you're going to have is you're going to end up with a resulting value of a 3 by 3. 3 by 3 matrix. Because once again, these two numbers match here. And so with that being said, you're going to have these two outer numbers, which is your resulting matrix here. So let's go ahead and move on. And we're going to do multiplication here of a little more complicated matrix. So I'm going to have A is equal to, we're going to make this into a 3 by 3. This is going to be a 3 by 3 matrix. So let's go ahead and do this, 3 by 3. And we're going to have, let's see, we're going to have 4, make that a little cleaner, 402. I really wish I had better handwriting. 402, let's do 1, 3, 5. And let's do 2. That's a 2, 1, 2. Okay, so, and then B is equal to, this is going to be, I'm going to make this a 3 by 2 matrix. So this is going to be a 3 by 2. 3 rows, 2 columns. So we're going to have 1, 4, 2. And let's have this be 2, make my 2 a little bit clearer there, 2, 0, 6. Okay, so our first thing we want to do here is we realize that this is a 3 by 3 matrix, 3 columns, 3 rows, so it is a 3 by 3. And we're going to multiply this by 3 by 2, 3 rows, 2 columns. So what we notice here, these two numbers match. So now our resulting matrix is going to be a 3 by 2 matrix. So AB is going to result in a 3 by 2 matrix. Okay, so I'm going to go ahead and draw it out here. So AB, let's go ahead and make enough room out here. And we're going to make sure that we have enough room to put our numbers in here. 3 by 2, that's going to be a 3 by 2. I'm going to make these nice and big. And so remember, we're going to have to multiply each of these rows by this first column, and then each of these rows by the second column to get each of our numbers to fill the dimension, to satisfy this dimension, 3 by 2. So first things first, you're going to multiply this row by this column. So how I like to do it is I'm going to come down here and I'm going to do row 1 of the first matrix times column 1 of the second matrix. And I'm just going to go ahead and do the multiplication in my head. I'll write it out, but I'm going to do the main parts in my head. So the first thing we have here is we have 4 times 1, which is 4. And I meant to put column 1, not column 2. So that's row 1, column 1. I keep putting 2 there. Okay, so we're doing 4 times 1 is 4 plus 0 times 4 is 0. And then 2 times 2 is 4. And so we get 8. So that is going to be our value that goes there. Now we have to do the same thing for the second row. So this is going to be row 2, column 1. Remember, column 1. So 1 times 1 is 1, plus 3 times 4 is 12. And I'm going to make that a little clearer, 12. And then 5 times 2 is 10. So we have 13 plus 10, that's going to be 23. So I'm just going to go ahead and put that there, 23. And so now we got to do our third row. And once again, this is a 2 here. So we're going to multiply this row by this column. So we're going to have row 3, column 1. Okay, column 1, there we go. So we have 2 times 1 is 2, plus 1 times 4 is 4, plus 2 times 2 is 4. So once again, this number is going to be multiplied by that number. We get that there. This is going to be multiplied by that number there. We get 4. And then 2 times 2 is 4. So yeah, make sure you don't, if you throw yourself off by making any simple calculations, you'll find yourself getting stressed out. And so I'm trying to avoid that by giving you guys a really good example. So hopefully I didn't make any mathematical errors here. So if we have 2 plus 4 is 6, that's going to be 10. Okay, so now we've pretty much taken care of our first column here, because once again, we know that this is a 3 by 2 matrix. And so we have 3 rows, but now we have to find our values for the second column. So now I'm going to come down here, and we're going to start back up at row 1. But now we're doing the same process we did over here, but now we're doing it for this second column. So row 1, column 2. There we go. So 4 times 2 is 8. 0 times 0, well, that's easy. That's plus 0. And then 2 times 6 is 12. And so that's going to be 20. So 20 is going to go up there. And then now we're going to multiply row 2 by column 2. So hopefully you guys are kind of getting the gist of what's going on here. So we're going to have 1 times 2 is 2, plus 3 times 0 is 0, plus 5 times 6 is 30, plus 30. So 30 and 2 is going to be 32. I know, this is really challenging trying to make that a clearer 0 here. And then we got to do our final row. So row 3, and then times column 2. We're almost done. We're on the home stretch here. And so coming back here, we're going to do 2 times 2 is 4, plus 1 times 0, that's a 0, plus 2 times 6 is 12. And so 4 plus 12 is 16. And that is our final answer for multiplying A times B. Now, we multiplied B times A. Well, you would have to, let's come back up here, and let's just, actually, let me just do that down here. We're not going to go through the entire process, but let's say we want to multiply B times A. So we come down here, we're going to have a 3, it's 3 by 2, so we're going to have 3 by 2. Let me make that in a time. 3 by 2 times, now this is going to be a 3 by 3. 3 by 3. And so what we find ourselves seeing here is this number, the second dimension of the first matrix, of what would be the first matrix, does not match. 2 and 3 do not match. So B multiplied by A does not exist. So it does not exist. So I hope you guys were able to withstand my handwriting. Hopefully you guys were able to kind of get the gist of how you multiply matrices. Let me just kind of finish off with some hypothetical scenarios here. Hypothetical scenario. Let's say you had C is equal to, I'm not going to draw it out. I'm just going to say that this is a, let's just say that this is a 7 by 1 matrix. Let's just say this is a 7, let's make it a 7 by 2 matrix. And D is equal to, let's do a 2 by, let's do 2, let's see, D is equal to, and this is going to be a 2 by, let's do a 2 by 3. So once again, if we're going to figure out what's going to be the resulting, what are the resulting dimensions? Well, so we do CD, that's going to be 7 by 2, let me make that a clearer 7, times 2, my 2's are horrible, times 3. And so what's going to be the resulting matrix? Well, these 2's match. And so the resulting matrix is going to be a 7 by 3. So CD is going to be resulting in a 7 by 3 matrix. And so I think I'm going to leave it at that. Now, feel free to comment. Let me know what you thought of my first tutorial. And I think this is going to be good practice for me to do, because in my career field, I'm going to have to learn how to present findings to either stakeholders. It depends on where I ultimately end up working at, but I'm going to be able to have to write reports, present my findings in concise terms for a non-technical audience. So it's kind of good I'm getting this kind of practice. Plus, it's also really good to be able to understand the theory behind these algorithms and the mathematical processes that are involved with them, because it's going to become crucial that if I can understand the mathematics behind machine learning, it's going to be really helpful. So I hope you guys got some useful insight and some good advice from this video. And hopefully, if any of you out there are taking a linear algebra class and are working with matrices, hopefully this helped you out. But once again, I thank you all for supporting my channel, and I'll be back with more. Peace out.